Why do so many people associate BMW with drifting? It is not only the sound of an engine, the shape of a coupe, or the reputation of the M badge. The real answer is hidden underneath the bodywork, in the way the car sends power to the road, the way its weight is balanced, and the way its electronic systems can either protect the driver from a slide or give an experienced driver more control over it. But here is the part most short videos leave out. A drift is not a magic trick, and it is not proof that a car is automatically better than every other car. It is the result of several engineering decisions working together. So how did BMW become one of the most recognizable names in the world of controlled oversteer? And why can one BMW feel playful and predictable, while another feels completely different? Today, we are breaking down the engineering behind the slide. Start with the layout. For decades, many of BMW's most enthusiast-focused cars used a front-engine, rear-wheel drive format. The engine sits at the front, the rear wheels provide the drive, and the front wheels are free to focus mainly on steering. That separation creates a very different sensation from a front-wheel drive car. When the rear tires lose some grip under power, the front tires can still point the car. The driver is not simply being pulled through a corner. The car can rotate around the rear axle, while the steering helps control the direction. That is the basic recipe for oversteer. But the layout alone does not create a great driving car. The car also needs predictable responses. If the grip disappears suddenly, the driver has very little time to react. If the transition is progressive, the driver can feel what the tires are doing and make smaller corrections. This is one reason enthusiasts talk about balance so often. A balanced chassis does not mean the car can never lose traction. It means the driver can understand the movement before it becomes a surprise. Every car is a moving system of mass. During acceleration, weight shifts rearward. During braking, it shifts forward. In a corner, the outside tires carry more of the load. These changes affect how much grip each tire can produce at a particular moment. A BMW designed around driver involvement tries to make those changes feel readable. The goal is not to remove every movement. The goal is to make the movement consistent enough that the driver can respond to it. That consistency matters when the rear tires begin to slide. A controlled slide is not simply more power. It is a conversation between throttle, steering, tire grip, suspension movement, and the surface underneath the car. Change one variable, and the entire conversation changes. More throttle can increase rear wheel slip. A steering correction can change the direction of the car. A different tire, temperature, or road surface can change the amount of grip available before the slide begins. This is why the same BMW can behave differently on a warm track, a cold track, wet pavement, or an ordinary public road. The badge stays the same. The physics do not. Next comes the differential. The wheels on the outside of a corner travel farther than the wheels on the inside. That means they need to rotate at different speeds. The differential allows that difference. But in a high-performance car, the differential can also influence how drive torque is shared between the rear wheels. When one tire has less grip than the other, the system can affect how effectively the car uses the available traction. In BMW M models, the active M differential is designed to vary torque distribution between the rear wheels as conditions demand. That does not turn the car into an arcade game. It simply gives the drivetrain another way to manage power when the car is being pushed hard. The result can feel more stable at the limit. Instead of one tire spinning away while the other struggles to contribute, the system works to make the power delivery more useful. But again, the hardware does not replace skill. A differential can change the character of a slide. It cannot remove the laws of motion.
Modern BMWs also add another layer: electronic stability and traction systems. These systems monitor things like wheel speed, steering input, and the vehicle's movement. When the car begins to rotate more than the system expects, the electronics can reduce engine torque or apply braking intervention to help stabilize it. For everyday driving, that protection is valuable. It can help the car remain composed when grip changes unexpectedly. But performance-focused BMW models can offer different levels of intervention. BMW's own technical material on xDrive describes 3 power transmission modes for certain M3 and M4 competition models: 4WD, 4WD Sport, and 2WD. In the standard 4WD setting, the system emphasizes traction while keeping a rear-biased character. In 4WD Sport, a greater share of torque is directed toward the rear wheels, creating a sharper response and making controlled drifts possible on a suitable closed course. In 2WD, drive power is sent only to the rear wheels, with the stability system switched off. That last setting is not a beginner feature. It is a reminder that the same car can be configured for very different jobs: daily control, fast-track driving, or a pure rear-wheel drive experience. The important distinction is this: electronic systems do not make drifting safe everywhere. They change how the car responds in a controlled environment. Public roads contain traffic, pedestrians, changing surfaces, and consequences that a performance video cannot predict. So why do some BMWs feel so natural when they begin to rotate? Part of the answer is steering feedback. Part of it is throttle response. Part of it is the relationship between the front axle, the rear axle, and the suspension. A driver needs to know what the front tires are doing. If the steering gives clear information, the driver can sense whether the car is turning, pushing wide, or beginning to rotate. The driver also needs a powertrain that responds in a way that can be modulated. A sudden surge of torque can make a small mistake much larger. A predictable response gives the driver more room to make a correction. This is why the best performance cars are not defined by one specification. Horsepower matters, but so do control, communication, and repeatability. A powerful car that feels unpredictable can be less enjoyable than a slower car that tells the truth. Here is a myth worth correcting. Not every BMW is automatically a drift car. Different generations, engines, transmissions, tires, differentials, electronic systems, and drive layouts create different behavior. Some BMWs are optimized for comfort. Some are optimized for efficiency. Some are built for all-weather traction. Others are designed around track performance. Even 2 cars with similar badges can feel different depending on their setup and condition. And a car that looks dramatic in a short clip may be showing only the most exciting 2 seconds of a much longer process. Short videos hide preparation, location, tire condition, and the skill of the driver. That is why educational car content matters. It replaces the fantasy with an explanation. The real appeal of BMW is not that it ignores physics. It is that in the right conditions, the engineering can make the physics feel understandable. So why did BMW become so connected to drifting? Because the brand spent decades combining a driver-focused layout with chassis balance, rear-wheel drive behavior, powerful engines, mechanical grip, and electronic systems that can be tuned for different levels of intervention. The drift is only the visible result. Underneath it is a chain of decisions: where the engine sits, where the power goes, how the differential manages torque, how the suspension communicates, and how the electronics respond when grip starts to disappear. That is the engineering behind the slide. And the next time you see a BMW rotate through a corner, remember, the impressive part is not simply the smoke. It is the control that makes the movement repeatable. This video is for education and automotive appreciation only. Never attempt drifting on public roads. Professional performance driving belongs on a closed course, with proper instruction and safety equipment. If you enjoy BMW engineering, performance history, and the real stories behind iconic cars, subscribe to Cars Aura. More long-form automotive breakdowns are coming.